everyone. Thanks for coming. We are very pleased to host the third session of RecsysFR. I just want to give you a short talk about recommendation at Deezer. So I'm Benoit Mathieu. I'm the head of data science at Deezer. Just classic numbers about Deezer to present to you. So Deezer is a music streaming company. We are more than 400 employees, and we recommend music. So we have a very large catalog of more than 5 million albums, 40 million tracks, and we have a lot more playlists. Currently, we have 16 million active users, monthly active users, and 6 million subscribers. I have also some technical numbers. Deezer is run by about 500 servers. We have 4.5 petabyte of storage for audio files. We ingest 1.5 terabytes of logs every day. We handle 1 billion requests per day. And we ingest about 30,000 new albums every week. We also benefit from our Hadoop cluster, on which we compute a lot of models to do recommendations. And so I will just give to you an overview of recommendation opportunities we have on Deezer. The most classical one is item recommendation. So on the website and on mobile too, we have slots, sections to recommend items. For example, on the homepage you have personalized playlists, which are recommended to you, and you have new release album. So it's a classical, typical recommendation problem. We have a catalog of items, and we must choose some items that the user is interested in. But we have also a very different case. We have personalized radio. When a user clicks on a radio, for example, folk radio or pop radio, it may mean different things for every user. So we want to build your folk radio or your rock radio, and we have to identify some subgenres and find the ones that you want to listen to. We also handle some parameters that the user can set if he wants to be in more discovery mode and got some new tracks he never listened to, or if he just wants to stay familiar with familiar tracks. Indeed, interactive radios comes with a very specific challenge. The user can skip tracks, can like tracks, can dislike tracks, and we have to understand those feedbacks and adapt the track list to find something interesting for the user. Just a brief overview of how we are doing that. Here is a slide that some of you may have already seen on last session. Here is the data flow of our computation. Usually we use our Hadoop cluster to compute some user data, modelize the users, and we export those data in classical SQL storage or other things. We also try to consolidate metrics on our catalog. We try to describe our songs, our albums with tags, and we compute some popularity metrics, freshness, and whatever we want. We store that in Elasticsearch. And then, when we have to serve recommendation for user, front-end script in PHP, usually retrieve user data from Memcache and SQL storage, and try to build a smart query to Elasticsearch to retrieve content relevant for the user. So that's how we manage to do recommendation. And then we have logs to track activity, what works, what don't work, and update our models. One important thing when we are doing recommendation prediction is to evaluate. We often do an A/B test to evaluate algorithm changes. We have several classical metrics, like the three ones here. We monitor the percentage of users who are listening more than 10 minutes the radio, for example, or the playlist we suggest. We monitor also reconnection and how much user likes or dislikes the content we provide to. One thing all of you must already know is that we have to take care about the statistical confidence of our metrics when we are doing A/B test. Indeed, very often we observe some variation on day-to-day between metrics we collect. It's often the case if we are testing on too few users, and so metrics are not statistically relevant. So take care of that statistical confidence. But A/B test is a great tool, but it's not the only one we have to use, because A/B tests are costly, and they take times to get accurate results. And sometimes we want to do many tests. And in particular, when we want to design new algorithm, we want to tune parameters, we have to check lots of combinations. So we can't rely on A/B tests to do that. So we also do offline testing. Offline testing is just setting up a benchmark for a specific recommendation problem. We set up a benchmark so we can run some simulation offline to evaluate what would happen on the website. The traditional approach we use is to freeze data at one time. We just keep the user state and the catalog state at one time, and we we collect what happened in the next 7 days to collect items relevant for the user, and we see if we can predict that the user will listen to those items with the previous date. Offline testing allows us to imagine lots of combinations, lots of parameters, tuning parameters, and so we can eliminate algorithms that don't perform well and keep only a few of them, and then we go in the traditional process, release process. So we do some user study to get fewer algorithms, and then at the end we can use an A/B test to select the best one. So that was just a short introduction about what we are doing at Deezer. Feel free to come and speak and talk to me or every other Deezer member here. Indeed, we have several open positions at Deezer for several type of work, data scientist, engineer, software engineer, sysadmin, lots of things. So if you are interested, do not hesitate to consult the webpage. So thanks for coming and enjoy the RecsysFR session.